First off, is this ready to be factored? Yes, it is, because it is set equal to 0. We know it needs to be factored because it has an x squared in it. It's a quadratic equation. If it didn't have that x squared in it, you would just solve it like you did in Algebra 1. So we are going to factor this. We can't do a distributive property because nothing goes into 1, 9, and 20, and all three terms don't contain an x. So x squared splits up into x and x, and two numbers that multiply to be positive 20 but add up to be positive 9 could be positive 5 and positive 4. Remember, if you can't get it to check out, 5 times x is 5x, 4 times x is 4x, and that does equal 9x. If it doesn't equal 9x, you've got to find two other numbers that multiply together to be 20 but add up to equal 9. Set each part equal to 0, so x plus 5 equal to 0, x plus 4 equal to 0. On the first one, I would just subtract 5 from both sides, so x equals negative 5. And on the second one, subtract 4 from both sides, so x equals negative 4. And there are your answers. So two answers on this one. Part B, can we factor it? Is it ready to be factored? And how do you know? We know it's ready to be factored because it's set equal to 0, and it contains, in this case, a y squared, so we're going to have to solve this by factoring. So what are two terms that multiply together to be 6y squared? Let's try 3y and 2y. 3y times 2y equals 6y squared. There's also 6y and y, so if this doesn't work, I'm going to have to go back and check 6y times y. And then I need two numbers that multiply together to be 20, but my outsides and insides will add up to be negative 23. Since they multiply to be a positive but add to be a negative, I know they both have to be negative. And let's see, what would work on this one to multiply to be 20 but add up to be negative 23? Well, let's see. Let's try maybe 20 and 1. What would happen if we did 20 and 1? Would that be two good numbers? Inside would be negative 2y, but outside would be negative 60y. So no, I don't think that would be two good numbers. So we don't want to use negative 20 and negative 1. So I would erase those, and I would need to try something else. What about 10 and 2? Would that be any good? So 10 and 2, that would be 4y, and negative 30y. Well, that's no good either, so let's eliminate those. And what else can try? How about 5 and 4? Would that be good? Let's do minus 5 and minus 4. So the inside terms would be negative 5 times 2y, which is negative 10y. The outside terms would be 3y times negative 4, which would be negative 22y, or excuse me, negative 12y. Oh, so close. We get negative 22y, but we need negative 23y. So those two numbers aren't going to work in their current position. Would it matter if I switched them around? And actually it does in this case, because if I put the negative 5 on the right side and the negative 4 on the left side, I'm taking those numbers times different numbers with y's. So negative 4 times 2y is negative 8y. Negative 3y times negative 5 is negative 15y, and those do add together to be negative 23y. So this is the proper way of factoring it. So since it's properly factored, we're ready to set each part equal to 0. So 3y minus 4 equals 0, and 2y minus 5 equals 0. Add 4. So 3y equals 4 divided by 3. So y equals 4/3. Add 5 to both sides on this one. So 2y equals 5 divided by 2. So y equals 5/2. So two fractional answers this time, 4/3 and 5/2. It's very common to do geometry questions with quadratic equations. This one says find x and the dimensions of each rectangle. So we have a rectangle that is x by 4 inches long and x times 2 inches wide. And then the a equals negative 432 here in the middle. That means that is the area. So we're going to have to think about geometry for a little bit. What is the formula for area of a rectangle? Formula for area of a rectangle is length times width, and that equals the area. So this is telling you that the length is x plus 4, so I do need to put that in parentheses because x plus 4 represents one measurement. And x minus 2 is the width, so I need to put those in parentheses, again, because the width is one measurement, and that equals 432. It's not, don't put the exponent of 2 in there. That just means it's in square inches because area is always supposed to be written in square inches. So it is very tempting to just set both of those parentheses equal to 432 and try to solve it. Except remember that the only way that factoring works, and this method works, is if it's set equal to 0. And this is clearly not set equal to 0. So we just can't set x plus 4 and x minus 2 equal to 432. So what we have to do on this one is that we have to multiply this out, multiply x plus 4 to x minus 2 together, move the 432 over to the left side so it is set equal to 0, and refactor. So let's do the double distributive property first. So take x times x, which is x squared. X times negative 2 is negative 2x. 4 times x is 4x. And 4 times negative 2 is negative 8. We can combine together the like terms, and we do have like terms. Negative 2x plus 4x is positive 2x minus 8 equals 432. And then again, to get it set equal to 0, I need to subtract 432 from both sides, and I'll put it under the negative 8 because they're like terms. So this will be x squared plus 2x minus 440 equals 0. So now we're ready to factor it. And yes, we do need to find two numbers that multiply to be negative 440, but only add up to be a positive 2, which means one of the numbers is going to be positive, one of the numbers will be negative. And they're going to be numbers that are fairly close together if you don't count their positive and negative differences in their signs. So the two answers on this one would be positive 22 and negative 20. When you multiply 22 times negative 20 together, you get negative 440. But again, when we add them together, you get 22x and negative 20x, and that does add up to just the 2x that we're looking for when we modified the problem. So then we set each part equal to 0, so we get x plus 22 equals 0, and x minus 20 equals 0, and we get two answers. We get x equals negative 22 and x equals 20. So which one of those answers is correct? Well, we don't exactly know yet until we plug them back in to find the dimensions of the rectangle. Dimensions are just the length and the width. So we got to plug those numbers in for x. So what happens when you plug negative 22 in for x? So you have negative 22 plus 4, and that means you would have a length of negative 18 inches. Well, what in the world does that mean to have a length of negative 18 inches? That really does not make any sense in the context of the problem because a rectangle is not going to have a negative length. So even though x equals negative 22 is really a solution to the equation, it doesn't make a lot of sense because it gives us negative measurements in our rectangle. So we're just going to ignore that part of the answer, and we're going to try the 20. So when we plug in 20, 20 plus 4 is 24. So the length of the rectangle is 24. And then when we do the width of the rectangle, it would be 20 minus 2, which is 18. So the dimensions are 24 inches by 18 inches. And if you multiply 24 times 18, what do you think you're going to get? Well, you're going to get 432 because that's what the area of the rectangle is. Finally, the last thing we're going to do is translate sentences into equations by working in reverse, by taking the two answers to an equation and working backwards to figure out what quadratic equation generates those solutions. So it says write a quadratic equation in standard form with answers with negative 1/3 and 6 as its roots. Remember, roots just means that's what the answers are. So if x equals negative 1/3 and x equals 6 is the answer, what set of parentheses would have generated those solutions? So thinking about this going backwards, what set of parentheses would give you an answer of x equals negative 1/3? Well, remember that you would have to do the opposite to both sides of the equation when it was set equal to 0 to get the answer. So the root, So remember, you would have to do the opposite to get the negative 1/3 as your answer. So you would have x plus 1/3 would generate a solution of x minus equals negative 1/3 because you would have to subtract 1/3 from both sides of the equation. So what would give you an answer of x equals 6? Well, that would, since it's a positive 6, the parentheses x minus 6 would give you an answer of x equals 6 because, again, you would add 6 to both sides of an equation and you would get x equal to 6. So that's why the signs are different. If we write it in standard form, that means we need to multiply it out. So the step above that would have been the pre-factoring step, and you can get to the quadratic equation by doing double distribute. So I would take x times x, that would be x squared. I'm going to write that over here. And then x times negative 6 would be negative 6x. And then 1/3 times x is 1/3 x. And 1/3 times negative 6 is negative 2. And then we do have like terms in the middle, as we often do, and negative 6x plus 1/3 x is negative 17/3 x minus 2. And since this is a quadratic equation, we do have an equal sign, and remember, before we factor anything, we would always have it set equal to 0. So you just set it equal to 0 to make it your quadratic equation in standard form. And another common thing to do, and sometimes you will see this, is that you won't see any fractions in the answer. So how can we eliminate all the fractions out of the equation on this one? And the way we can do that is multiply both sides times the common denominator. And the common denominator, since there's only one denominator, is 3. So by multiplying both sides times 3, I still have 0 on the right side of the equation, but the left side would be 3 times x squared, which is 3x squared. 3 times negative 17/3 x is negative 17x, and 3 times negative 2 is negative 6. So I would accept either x squared minus 17/3 x minus 2 equals 0 as an answer, but I bet you any answer key probably has it without fractions, and they would have it like that. Let's try one more. Write a quadratic equation in standard form with 3/4 and negative 5s as its roots. So if the answers were 3/4 and negative 5, the sets of parentheses that would give you those answers would be x minus 3/4 and x plus 5. And then we would multiply it out. So x times x is x squared. X times 5 is 5x. Negative 3/4 times x is negative 3/4 x. And negative 3/4 times 5 would be negative 15/4. And then we would have our like terms in the middle. So we would have x squared, and then we'd have to add 5x to negative 3/4 x, and that would be positive 17/4 x minus 15/4. Again, equals 0 because we're trying to write an equation in standard form meaning that it is set equal to 0. And then we can eliminate the fractions by multiplying both sides by the common denominator, and the only denominator is 4, so that would be our common denominator. And then distribute, we would have 4x squared plus 17x minus 15 equals 0. And that would generate the roots of 3/4 and negative 5.